So students, this is a sample video for chemistry class. This is your periodic table. See students, here there are 118 elements present. In this, total periodic table is divided into 4 parts: S block, D block, P block and F block. Total there are 4 blocks in the periodic table. If you take S block, these are the S block elements: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, beryllium, magnesium, calcium, strontium, barium and radium. Students, in S block you are having 2 types of metals: alkali metals and alkaline earth metals. If you see the alkali metals, these are the alkali metals highlighted. Alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. Then alkaline earth metals are beryllium, magnesium, calcium, strontium, barium and radium. This is about the S block, in which you are having hydrogen additional element, which is not a metal. Students, it's a non-metal. Still, hydrogen position is not yet defined, where to place it, whether with the alkali metals or with the halogens here, fluorine, chlorine, bromine, iodine. It is not yet confirmed, but time being it is kept here. Then you are having another block, that is P block. So P block elements here, they are highlighted, students. You can count how many they are in number: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, and here 37. Total 37 P block elements you are having. Okay, students? Then in this you are having a mix of metals, non-metals and metalloids. Now what are metalloids? Students, metalloids are highlighted. Metalloids are those elements which have some properties of metals and some properties of non-metals. Some properties of metals and some properties of non-metals. Not all properties of metals and all properties of non-metals. So metalloids or semi-metals have some properties of metals and some properties of non-metals. What are those? Boron, silicon, germanium, arsenic, antimony, tellurium and acetylene. Okay, how many are in number? 1, 2, 3, 4, 5, 6, 7. That number also you have to remember. Then you can also see all the metals. So this many metals are present in the periodic table. So majority of the periodic table elements are metals. Metalloids are very few in number. First rank is metals, they are abundant in the periodic table. Then non-metals, then metalloids. If you see non-metals, just non-metals, only non-metals, this many are there. So after metals, who are in majority, students? Non-metals. Non-metals are less. Okay? Then metalloids are very less. Now students, what are transition metals? This comes under D block. So after completing the P block, you are having a D block, which is at the center of the periodic table. This is the center. So scandium, titanium, iridium, chromium, manganese, iron, cobalt, nickel, copper, zinc, yttrium, zirconium, niobium, molybdenum, tungsten, ruthenium, rhodium, palladium, silver, cadmium, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, mercury, rutherfordium, dubnium, siborium, borium, hafnium, meitnerium, damstadium, rhonginium and copernicium. So if you count this, how many are in number, students? If you leave this column, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 4 nines, 36, 37 and 38. Total 38 elements are present. So these all elements are metals. D block metals you can also say. Okay. So D block scandium to zinc, this is constitute one series. This is one row which is called as 3D series. Because in these elements 3D subshell is being filled. It is called 3D series. Then yttrium to cadmium, this is second row, that is nothing but 4D series. It is called as 4D series because when you write the electronic configuration of these elements, the last electron will enter into 4D. In the first row, that is 3D series, the last electron, when you are writing the electronic configuration, enters into the 3D subshell. And in this second row, that is the 4D series, the last electron, when you are writing the electronic configuration, enters into 4D subshell. 4D subshell. Then this is 5D series, means 5D subshell is being progressively filled. Last entering electron enters into 5D. Then this is 6D series. It means the last entering electron enters into the 6D subshell. Like this, we are having some series here. Okay. So these are also called as transition metals. Now the question arises, all these elements are called as transition metals? Answer is no. All D block elements are not called as transition metals, but all transition metals are called D block elements. Now what are transition elements? Students, transition elements means, or transition metals means those metals which are embedded between the metals and non-metals. Here what you are having, students, metals here. Yes or no? Metals. And here you are having what? Non-metals. Metals and non-metals. These are highly active metals, and this side these are more reactive non-metals. Then between them equipped are the transition property. These elements are not too metallic, So there is a change happening when you are going from right to left to right. That's why this is called transition, change. Then you are having, students, lanthanides. What are lanthanides? Lanthanides are below yttrium. Here you can see yttrium. There is a yttrium here. Below yttrium, these 14 elements are present. That is from lanthanum, cerium. If you count this lanthanum, it will become 15 elements, students. If you does not include the lanthanum, then there are 14 lanthanide elements, starting from cerium. So what are those? Cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. If you include the lanthanum, it becomes 15 elements. Okay? When you are studying the lanthanides from cerium to lutetium, you will also include a lanthanum element, because that lanthanum element property matches with the rest of the 14 elements from cerium to lutetium. Then after that you are having actinides. Actinides come after, or you can say before actinium. Lanthanides will come after lanthanum, then actinides will come after actinium. This is actinium. Actinides will start from here, thorium to lawrencium. That is nothing but, what are those? Thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, and lawrencium. So if you don't include this actinium, there are 14 actinide elements. 14 lanthanide elements and 14 actinide elements are present. So this constitutes what? A block. 14 lanthanides and 14 actinides. If you include lanthanum and actinium, it becomes 30. If you don't include lanthanum and actinium, this lanthanide and actinides together they are 28 in number. That is 14 lanthanides plus 14 actinides. Then, where are the non-metal situated at the right hand side of the periodic table? Noble gases, students. Noble gases means they are like, you can say, adarshwadi elements. Means those elements which the other elements will see and want to become like that. Noble gases. Noble gases are stable elements. Yes or no? They are very stable. They are inert. They do not readily participate in the chemical reaction, in chemical bonding. So other elements also want to become stable like these noble gases. For that purpose, the remaining elements, they try to either lose electron or gain electron, or they share electron. They do something to somehow become the noble gases, stable like noble gases. Students, we are also, what we do? We also daily we will try to stabilize ourselves. Every system in the universe try to attain stability. Yes or no? Now, morning I ate breakfast. Then by the time of 2 o'clock or so, afternoon, I will become very hungry. Okay, I feel very hungry. 3 o'clock, very hungry. I feel myself unstable. Then to get stability, what I should do? I should take food. I should take water. I should drink water. So every system in the universe, like human beings, also try to attain stability. So here, like noble gases, the other elements also will try to attain stability, either by losing electron or by gaining electron or by sharing electrons. Is that clear? Then what are reactive nonmetals? Reactive nonmetals means these are the nonmetals which readily participate in the reaction. Generally, nonmetals have the ability to gain the electrons. They gain the electrons. So they gain the electrons very quickly and form negatively charged ions which are called anions. Negatively charged ions are called anions. Positively charged ions are called cations. So nonmetals will form anions. Metals will form cations. Students, like this, many important points are equipped in the periodic table. So this is a bridge course. In bridge course, we can't discuss in detail all the points. See, bridge course is meant for a gap between your dream, that is NEET, JEE, and your 10th class. The gap is what you call as bridge. So that bridge course will help you in transformation for you from the lower classes to higher classes. You will feel very comfortable when you go to the higher classes, 11th and 12th, with this basic foundation knowledge. Students, what I have explained here is just a fraction of the part of the predictable. So if you come to the regular classes, you will definitely have a fun, you will learn more, and you will feel very comfortable when you go to your 10th, 11th class and 12th class. There you will not feel uncomfortable. You will be very free to answer the questions there very quickly. So students, try your luck. All the best.